Okay, so welcome to the sixth meeting of this course. Mazal, you wanted to talk about something and discuss the assignment?
Yes,
Okay, please. Would you like to share your screen so we can see
yes.
what's the...
Okay. I can also open my Git. Do you see the whole screen?
I see your browser now.
Yeah, okay, good. Okay, so I did the assignment and then I had really big problems with the ignore and PyCache folder. I read your blog and I also watched the video,
Mhm.
but like I don't know why sometimes when I uploaded my at first I in this folder I only had these 3 files of the assignment. And then when I uploaded it to the Git, it
Yeah.
automatically, sometimes it only uploaded 3 of them as the first
How do you upload?
from the CMD, like this. Git add, git commit, git push.
Okay, so what you need to do is, I mean, I see that you have a .gitignore file in this folder,
Yeah. So
but
sometimes,
that's not useful. I don't know what sometimes happens. Okay, so I don't know. I
okay,
know how it works. Okay,
okay,
I don't really know. I mean, I don't know what you did and how you did it. That something happened, and I'm
okay,
not sure that we can figure it out. I can tell you how. I mean, maybe there are other ways it works, but I know one way, and that's what I'm teaching. Okay.
yes.
So the gitignore file shouldn't be in this folder. It should be in the root of the repository. So it's
Can
one
I,
file. Yeah. So the way
can
to
I,
wait before you do this anything. Yeah. Here on the CMD, type in the following command. Type, just the word type, space, and then .gitignore. And you can tab complete here. Yeah. So this command on Windows shows the content of the file. Okay.
yes,
Okay. On Linux and the Mac, it would be the command cat, like the animal cat. Okay,
okay,
and then the name of the file. Now we would like to, so the content of the file is good, but the location is not. Okay. If you now run dir and then space and 2 dots, okay, that shows the content of the folder above.
yes.
And there's no .gitignore, and that's the problem.
Oh, I
So
see.
we need to move it. Now the file is already known by Git. Okay. So the ideal way to move it is by telling Git to move it. Okay, so Git
So,
will be able to know that, oh, this it's not that the file system, okay, so there's a separation between the file system, meaning your computer, whatever, well, the file system, okay, and where the files are, and what files Git knows about. Okay, so you can't just simply move it, let's say, with the file explorer. We also have to tell Git that the file was moved. Okay, and the way it can be done is that if you type in Git space mv, because it's move, and then the file .gitignore, again you can use tab completion, and then 2 dots, because you are, and you can put here a slash. You don't put the slash. This means move the gitignore file one folder up. Actually, we should have done something else before, but okay. Run git status now. No, just run. Yeah, okay. First of all, you can see that the file itself moved, but also if you
yeah,
run git status, you will see that Git
yeah.
knows about that the file was, well, it's called renamed, but that's the same idea. Okay,
Yeah.
so that's one
So
thing. And
now
and
git add.
you don't need to add, because it's because you did it with git move, it's already in the staging area, so you can
Oh,
it's enough just to git commit. Okay, But wait a second. Okay, so I should have done this in the other direction, other order sorting, because we first moved this, and the better way would have been first to remove the files that that shouldn't be in Git. Okay, so if you now run dir here, dir here, there is there's the underscore PyCache, and we would like to remove it. So type in git remove, git rm actually, and again I would, yeah, okay, I wouldn't copy paste this way, but I would use the tab completion, but it's at the end it doesn't matter. Okay, run it. So enter. Okay.
Oh.
So now that what it says that it can't remove just one. Git remove would be able, as it is, to remove a single file. But here in this PyCache, you have a folder that might have subfolders and files somewhere in. So you need to recursively remove it. Okay, we learned about the recursion, the same idea. The way to do this is to provide this -r flag. Then RM understands that it has to go all the way. Yeah, enter. Okay, so now we told Git to remove these files, and they are gone. Okay. For you, it doesn't matter that they are gone, because the next time you run your program, they will be recreated. Okay, and that's why we don't want to store them in Git, because these files are generated every time we run the program. Okay, and they are also different based on the. So before I go on with the Git part, you can see that the name of the file contains that it's the word CPython, right?
Yeah,
and 312. So the CPython refers to the Python that the type of Python that you have. There are various types of Python, and we just use the CPython, so that's why I didn't get in too much in detail. It's not that important for us. And the 312 just means that you are using version 3.12 of Python.
Okay.
Okay, but this sort of indicates that these files are different based for different types of Python, and for different versions of Python, they are different. And actually, they might be different also for different operating systems. Maybe that they have removed that, I'm not sure. Okay, so meaning that if you supply this file, for me, they are useless because I use a slightly different version of Python. Okay.
Yeah. So do I need to commit the changes now?
Okay, so Git status, just so we can see what Git thinks about this, what this Git remove. So it's also staged. By the way, you can see it because it's green, but it's also said changes to be committed. That's how you know that it's something that it's in the staging area already, or marked staged. And then you have to commit the changes. And remove unnecessary files or whatever. Remove generated files, but it's also okay.
Yeah. And so now I can push it, right?
And then you can push out the changes. Okay. And
okay.
Although what you did is removing something, this git push will tell the remote Git repository, basically GitHub, to also remove, to reflect whatever, to synchronize basically. So this git push or git pull is basically telling it to synchronize whatever you have. You're just telling it in which direction to synchronize.
Yes.
Okay.
Okay, I see. So now I have another question. In my repository, I have a lot of like folders, day 1, day 2, day 3.
Just a second, wait a second. I just want to add some comment here. So, because there were, and I even sent an email, quite a few people were missing this git ignore file, okay? And therefore, either they mistakenly added these files, the PYC files, or maybe they didn't add those files, but then when I run the program or anyone else runs the program and these PYC files and are generated in the PyCache folder, then they appear. If I run git status, I see them. Okay, and the problem with that especially when you if you start cooperating with someone else, so two people start working on the same code base, that maybe you remember not to commit these files, but the other person might forget, and they might mistakenly commit add these files to Git. So it's better to set up this git config file, gitignore file, so no one will mistakenly add these files. Okay?
Yeah. But sometimes they're only created after the first commit. So you need like to do the
I don't think so. I don't know. Maybe for some reason. Oh, I think I know what you mean. So probably you only saw that there is a PyCache folder, sort of pending to not. Okay, I'll show you something. Okay, if you now run git status. Okay, it seems that everything is empty. Now create a directory. You can do it in locally, or you can use the file explorer just to create a folder here inside day 5. Name of the folder doesn't matter, XYZ, let's say. Okay, just create a new folder, call it XYZ. Okay, so physically you see that there is a folder now. Let's say git status. What happens? It doesn't know about it. Now in the folder, in the file explorer, go into go into the XYZ folder and create a file here. Doesn't matter, again, abc.txt. Just some text file. Doesn't have to text file. Okay, that's fine. Okay, enter. Okay, now let's go to the git status. Okay, so now it says that there is a folder called XYZ that is untracked. It doesn't tell you about the files themselves, and probably this is what you saw. Okay, because that's how Git sort of works. It says, okay, if it's a folder that I don't know about, then I won't detail you what files are in that folder, because the whole folder is unknown for Git. Okay,
yes.
The file is there. Okay, so now if you add git add, it will add all these the folder and the content of the folder. Okay, so probably this is why you didn't see the files before the commit.
Okay.
Okay,
and
you can
now if the gitignore is in the root of the repository,
yeah,
so it should contain everything that I want to ignore, including other folders, right?
yeah. So
it cannot be separated for each day, let's say.
Well, the format of the gitignore file it can be very complex, and there are lots of documentations on how to write a gitignore file. I think I sent you in the email a link to one of my projects where it's quite extensive. Would you like to?
Yeah.
Can you? You can just go to GitHub. Maybe it's the best. Just open here. Open another. It's called github.com/subgob. So, which is GitHub is with a U. I have no idea what GitHub is, but maybe it's better not to open. SZAB, so mine, and then instead of the viz, type in pydigger.
Like this?
Yeah, I think it's that, or maybe there's a .com at the end. Not the old, no, or maybe I sent you this one. I don't remember. Even this one is fine. Scroll down a little bit, and there is the gitignore file. Click on it. Probably even here. This is an old version of something. Okay, so here you can see it's not that interesting. I'll show the other one. But here also you can already see that it says the first line: ignore every file anywhere that has an extension SWP.
Yeah.
And then the PYC extensions, because back then it wasn't in the PyCache folder when that was 10 years ago when I wrote this project, and there's a newer version of it. And then it says, ignore the WW folder, let's say, okay? Now, the way it's written, it ignores any WW folder in anywhere, okay? I could have put a slash at the beginning, so let's go now, instead of pydigger old, remove the minus old, okay? In the URL. Yeah, and probably it won't. Okay, so just okay, so instead of that, so remove the minus old and put there .com. Oh, okay, I forgot the exact name. Okay, so here go to the gitignore file, and that's just simple examples. So here, for example, you can see line 4, it starts with a slash. So it means that only ignore this when folder if it's in the root of the repository.
Mm-hmm. Yeah.
Okay, and you could say like really map things. Okay, in the day3 folder, ignore file data.txt, let's say. Okay, but it won't ignore now in other folders. You can say these things.
Mm-hmm.
Okay,
Yes, thank you.
you're welcome. It's a I mean, there's a lot of things you can say with this gitignore in order to make sure that it's usually what do we want to exclude or ignore? Generated files like the PYC files in this case. You can see lower here the .back file, backup files. Sometimes you might have data for your project. So you have, let's say you write some project that analyzes Excel files. And you don't want your data to be mistakenly added to the source code because let's say the data is private. Okay, so you will make sure that you exclude, let's say, all the .xlsm, whatever the extension of Excel files is. So you can
Yeah,
do,
I see.
right? Okay, so
Yeah,
these
I
are
don't
the
know
files.
why when I upload it, sometimes it created it, sometimes not. Sometimes I had to hit ignore in another folder. It was very not clear, but thank you.
Well, so everything, the gitignore is only in the, as far as I know, it's only in the root directory. I don't think that it's relevant in any of the other directories. Okay, and from
Okay,
that,
yeah.
there you can control all the folders.
Okay, thank you.
You're welcome. Any other questions? Anyone else wants? Okay, let me share my screen. Yeah. Okay. So we are going to talk a little bit about exception handling. And I actually wanted to show you also kind of continue dealing with files, reading files, especially reading, but also writing files. Okay, so I think we've already basically learned how to read from a file. I'm not sure if we also wrote to a file, but it's quite similar. But there is a huge issue, and some people already used exception handling. Probably, I don't know, either learned earlier or copy pasted from somewhere, doesn't matter. So what is exception handling? You already saw that sometimes our programs just, while it's already running, it crashes. Okay. So for example, let me show you here an example. I have a couple of files here to use. In each one of these files, it's hard to see, but it has a number 3 in it. So the file 3 has the number 3 in it. And the file 0 has the number 0 in it. Okay? And so these are just for demonstration purpose. The idea, and let me close all these things now. The idea is that I would like to open the file. So I get the name of a file on the command line, open the file, and then divide, let's say, 100 by the number that I have in the file. And obviously, if someone gives me the file with the number 3 in it, then it will work. But if someone gives me a file with the number 0 in it, then division by 0 won't work. So let's create a file, and let's call it in the day 6. Process text files by. Okay. actually, before, okay. So we start with defining a main function that prints hello, and then we are calling it. Okay, let's just go slowly. I can run this now by, oh, I forgot, sorry, I have to close this. I forgot to load my virtual environment. So source when bin activate code, okay. Right. So now I am back here and I'm going to run Python and process text files. Okay, so it will print out hello. I would like to get, and let's start not with the division part, let's start with the reading of the file part. So I'm going to get now a list of files and I would like to read them one by one. So I am going to import sys because I would like to get the names of the files on the command line. And someone asked me, what does sys do? And so to clarify, sys is a module. Sys doesn't do anything. This is just some more Python code, probably Python code. And it has various attributes. And one of the attributes is this argv, print sys argv. So when I clicked on dot here, it shows me all the attributes of the sys library. And I don't know if I am using any of the other, probably yes, but I forgot which one I use. I think I primarily, from this library, I'm primarily using just the argv usually. But there are all kind of other attributes that might be interesting. Okay. Okay. So I just use this. So an argument is some data. Okay, it doesn't do anything. Actually, it's just some data. So now I don't need this hello anymore. It was just there, so I can see that something is working. Okay. So now if I run this program, it will give me the list of values on the command line, starting with the name of the program. Okay, that's the first one. And then whatever I provided on the command line. So I would like to provide here the names of the files. Let's say 2.txt, 0.txt, and 3.txt. Okay, so now I gave them four file names, and you can see that these are all in this list, in the sysargv list. So we can go over them now. Okay, I can comment this out. I don't need it anymore. For file name in sysargv, and then let's first of all print the file name. Okay, just so we can see what we are doing. Okay, so here now I'm going to go over each file name, and instead of printing them just in one line, I'm printing them on the line. Okay, on one file name on each line. Now, of course, this one printed also the name of the program itself, but we don't want to, that's not the data, right? So instead of going over the whole sysargv, we are going to take only the part that starts from index 1 till the end. So this way I can tell, basically I could say here from index 1 to index 3. Okay, let's see first this one. Okay, so I can explain this. Okay, so index 0 is the name of the program itself. Index 1 is this file, which is called 1.txt. And then index 1, index 2, index 3. Okay, so here I said between 1 and 3, but in go over the range of these values. But in general, in every range in Python, the left side is included and the upper side, the right side, is not. So here it says start from 1 and go on up until you reach 3, but 3 is not included anymore. So it's only index 1 and index 2 it will work. Okay, the index 3 it won't include. Okay, this is how I could go over any list. Okay, so it's now I'm showing it on the argv list, but we already used other lists. So there might be a list of, I don't know, DNS sequences or a list of animals or whatever. And this way you can get a slice of that list. Now, what I started to do here is saying without the end number, this means from 1 till the end. Okay, if I don't say when to stop, then it will only stop when we reach the end of the whole list. So if I run this now, it will go over all the names of the files. So far, so good. Any questions? Then stop me and ask. Okay. So now what I would like to do is open the file and read the content. Okay. Open. How do I write it? With open file name as file handler. Okay. And then content equal to fh.read. So far looks good, right? Okay. What happens now? I run the program and it says, well, it dealt with 1 and it was about to deal with 2. Okay, it printed out the name and then I got an exception. This is called an exception. Python just stopped running. Okay, and it gave me an error. And we saw some of these already. Probably you saw earlier. So what was the problem? The problem is that I gave it the name of a file, and then you can actually, if I run it, ls here, okay, ls -l, you would not run dir because you're running on Linux. You're running on Windows. So on Windows it's dir, and on Linux and Mac it's ls or ls -l. Here you can see, actually, if I run ls -1, that would be just the names of the files. So you can see 1, 3, and 0. There is no 2. Okay, there is this other files, but they are not relevant for us. I don't know what this text is actually. Okay, so there is no file called 2, and this is how I ran the program. I gave it a name of the file, and this was my intention to show you that how to deal with the case when, let's say, your user supplies a name of the file that doesn't exist. Okay. So what happened here is that, and I run it again, it processed the file. It processed. I mean, fine. For now, the processing is just reading the file. Okay, it processed the name of the file, but then next file it it threw an exception. Okay, we are using either the word raise or throw when we are talking about creating or generating or whatever an exception, and we are talking and this, I mean, sometimes we use this word, sometimes that word, same meaning, and then we have to somehow catch the exception. No, forget about it. I'll talk about it in a second. Okay, so this is the error that we saw, file not found error. Okay, fine, because really the file doesn't exist. And then if we go upwards from here, we can see where this came from. So you can see that it was in line 7. It happened in line 7 here. And then you can go up one more line to understand how did we get to this line 7. And it says line 10. So this line called that that function, the main function. Okay, so we know that we will have a problem, but before I try to deal with this problem, okay, I would like to continue the process, continue the development of the script, so it will do this division by 100 by this number. But what you can notice already that it handled 1, it couldn't handle 2, and then it stopped. It didn't handle all the rest. So we have the 0 and the 3, and it didn't handle either one of them. So, and that's one of the problems that we have. Not just that the program gave me this nasty error message, and you don't want your users to see nasty error messages, but it's also that it stopped running. So let's try this now. Let's try this whole program with just one parameter. one txt. Okay, just one. Okay, now it worked, but let's continue. So I read the content, then I can convert it into an integer, int content, and then divide 100 by this integer. Okay, and the result, I put it into result equal, and print out the result. Print, and I would like to say that 100 divided by content is equal to result. Okay, let's see how it works. So I run it with the file 1, and it looks fine. Okay, 100 divided by 1 is 100. What if I use it with 3? Okay, that also works fine. Okay, so these two worked fine. Okay, so the program now works fine. But what if I would like really to give it a list of parameters? Now, what it says is that it did the work for the first file, and then the second file had this exception. So one thing that we could do is verify that the file exists. Okay, there's a way to verify that the file even exists, and if we can read it, and so on. And we can do that, but right, and that sort of might prevent this exception. But what I would like to do is say, okay, I would like to catch this exception. What happens here is that there is an exception here, and it starts going up in this what we call call stack. This is the call stack, okay? And someone who called this function or who called this code can catch this exception and say, okay, let's see if there is an exception here. I would like to deal with it. Okay. What shall we do? In order to show it, I'll do one more step of preparation. I would like to take this whole thing and move it into a separate function. So let's see if it works now. I think I already tried it and it didn't work. It's called refactoring. Let's try in the editor. I click on refactor. It says extract method. Yeah, nice. So what it did, it took all the content of what I'm highlighted, moved it into a function, and even arranged the file name to be passed to this function, and gave it the name new function. I could run this program now again, and it would behave exactly the same way. Okay, this is called refactoring in general. The idea that you change your code to make it more readable, let's say, or more maintainable, without changing the actual results. And the most simple refactoring is when you rename a variable. Let's say you had a variable name called data because you didn't have a better idea of how to code a variable name, or X because it's even easier. And later on, either Gabor told you that please use a more useful, more meaningful name, or you yourself found yourself in a position that suddenly you have a better name for that thing that you put in this variable, and now you would like to rename it to make your code more readable. And then you change the name of that variable name. And this is just this is refactoring. This is called refactoring. And luckily, the Visual Studio Code provides us with some tooling for this. So I could do manually, I could have done this whole thing manually, right? Just moving out the part of the code into a separate function. But Visual Studio Code provides us with this feature that allows us that helps us with refactoring. Now, the new func name, of course, is not really good, so I would like to change it. Again, I could just change here it to XYZ, and then come here and also say XYZ. I could do that, but I can also use I click, double click on it, press F2, I think. Let's say I press no. Renames, F2, I just, oh, because I pressed F1, sorry. Huh, okay, let's see. I'm pressing now F2. Yeah, okay. So I mistakenly pressed F1. I pressed F2, but also the same would be that if I right click, and then it says rename symbol, that's F2. And now I can type in the new name, and let's say process file, press enter, and then it replaces all the places, both where I'm using the function name and when it's defined. So it's nice. It's very nice, this feature of Visual Studio Code. Okay, so now I made it a little bit clearer. And by the way, now if I run this program, you can see that earlier we had 3 lines in this error. Here we only had 2 lines, sorry, 2 lines. It was line 7 and line 12. Now it has three levels of this call stack, because it says now the error happens in line 10, right? In this one, when it's trying to open the file. And we got there by calling in line 6, calling the process file function. And we got here from line 15, calling the main function. And this whole, what we call call stack, can be really, they also call it traceback, okay? It can be really helpful to understand not only where the problem is, but how did you get to this problem? Okay, good. So now we have this, but we have this problem of this exception. So the question is, where can we deal with this exception? Okay, with the fact that we don't have a file. I mean, the exception is here. The way we can deal with it, let's try it first way. I type in try, move this part in the one level deeper, and then I put here except, and put here the type of exception I'm catching, exception. Wait a second, file not found. Okay, here is the name of the exception that I just got, so I'm going to copy paste that. Okay, this is the exception, and here I need to do this is something. Print file name was not found. Okay, so what does this do now? I'm calling this with open, okay, reading the content. If this is successful, then this whole except part doesn't happen. If this raises an exception like what we saw here, then instead of stopping the whole program, it will check whether the exception is of this type, file not found error. And if it's this type, then it will execute this code and then continue. So now it's still not good what we are doing. And let me try it with this only with two now. Okay. So what happened now? Let me run it again. With 1, it worked. With 2, it says it reported file 2 was not found. So it printed out this message. But then we went on and tried to divide the int content by the 100 by the int content. And it said unbound local error, cannot access local variable content. Okay, so this variable content doesn't exist now, because in this call of the function, I was supposed to create it here, but because this open didn't work, this part already didn't happen because this sort of stopped. And instead of the reading of the file, we printed out that the file was not found, but that we pretended or didn't think of as if we could already read the file, and we couldn't. We actually can't do this, right, if the file is not found. So what we need to do here at this point is calling return to stop this call of the function. Okay, so now what we're saying is that, okay, we're trying to open the file. If it's successful, then this doesn't happen. Then we go on and do the division and the printing. If this file doesn't exist and we get a file not found error, okay, then it will be printing out the error message and returning from this function. And then we don't do the division. So now if I run this program again, it looks much better. We don't get this nasty error message. We get a much more, much nicer and still useful error message. Any questions here? No questions? Okay. So let's continue. Okay, then let's run this now. This, where was it? This way. Okay, so I'm now providing all the 4 file names. I run the program, and again, I get an exception. Now this one is a different one. It's called 0 division error. Okay, why does it happen? So what happens here? We take the 1 and divide, that works. Take the 2, it says not found, but it doesn't crash. Then goes to the file 0, which exists, but it has a number 0 in it. So it does the when it tries to do the calculation, it says there's 0 division error, because we were trying to divide 100 by a 0, and that doesn't work. So what can we do? Well, we can say, first of all, we can say if int content equal to 0, then print it can't divide by 0 and return. That's 3. Oh, now it works. We have 1 error message, we have the 2 error message, second error message, and then for 3 it worked. Okay, so in this case, the first one I was catching the exception, and the second one I was preventing the exception from even happening. Okay, let's save this now. Okay, so that's fine, but in reality, it might be the case that someone implemented this process function in some other file. So let's see, actually, let's move this to some other file. Let's call it mylib, just for the sake of it. And here we are going to import from mylib, import process file. Let's see. Still works. And you see, I'm committing the changes. Once I made a little change and the code and I try the code, I ran the tests. If I had tests, I would run the test, and it works, then I do the commit. Why? Because if I make a lot of changes, and then everything is in each change is really good, but at the end, when I'm really hungry because it's lunchtime, and I make a mistake, and then I break something in the code, and now it might be okay. Sometimes it's relatively easy to get back from there, but sometimes it's rather hard to revert that last change that you did just 5 minutes before lunch, and now suddenly you ruined all the 3-hour works from the morning. Okay, if you were committing after every small change that was already working, then you ruined only that 5 minutes of work, and you could reset that thing and go back, and all the other work is safe. So that's why when I'm using version control, it's pretty useful to commit all the time locally. I don't have to push it out because that's not really interesting. The important part is that I very frequently commit changes. Okay, I know people who commit changes once a week or once a month, but that's because they don't really understand how version control is supposed to work. You're supposed to commit very frequently. That's cheap at the end. You just have to have the process of doing it, and you have to all the time you have to come up with the explanation of what did you do now. Okay, so now I separated it. And why did I do a separation? Because I wanted to tell you a little story, basically. What happens if this file actually comes from some external library, and that person didn't handle all this? That person just implemented, and I'm going to copy paste this whole thing now, so you'll have the old one here. Okay, I put them here in commented out version, and I keep working on this one. So let's remove this whole exception handling from here, and the prevention. Okay, this is the code that the other person gave you. Not even that. Maybe this print of file name is not in the code. It's here. Okay, and I get the result from the process file back. So instead of printing here, I'm just calling return result. Except that I don't have the content there. Yeah, actually it's fine. Shall I put it even back? Okay, I can move it back, sorry. Maybe that's also fine. Okay, so let's keep it this way. Okay, so now I removed all this error handling from the code. I left the old one here. I only have the opening of the file, and then the division and printing out the result. So if I run this program now, I get back to the same problem that at 2, it will raise an exception, and it doesn't continue. But now, imagine that this was actually coming from someone else, maybe coming from the internet. You downloaded it and installed it. So you can't change this code. Okay, you can only change your own code. Okay, so how do you handle this? Now we can wrap this whole thing. Okay, I don't have the result here anymore. Okay, we can wrap this whole thing into a try and say except file not found error. And then I'm just going to copy paste it. Okay, Okay, now I don't need to call return because I'm just going to next iteration of this loop. So what happens now? Tries to divide by 100, okay? And then I get this exception, the error report. 2 was not found. Then trying to open 0, it works, but I get a 0 division error, okay? Now I can't do the prevention because everything is inside this process file, okay? I can't myself do the prevention. So I need to also catch this exception. Okay, let me stop for a second with the technique and let me try to explain or give you an example for this. So let's say you did some experiment and the experiment generated you lots of Excel files, CSV files, okay? And I'm using this text file for the simplification of the idea of having those Excel files. And then you have some library that someone else wrote, okay, that can analyze these Excel files, okay? Does all kind of calculations, opens the Excel file, reads the Excel file, and one of the calculations is a division. And now what happens if in one of these Excel files, there is a 0 somewhere, and it's trying to divide by that value. And the library, the author of the library, didn't think about the possibility of having their 0. Maybe it should be invalid, but maybe it was just a mistake that the author didn't think about it. But it can happen, right? And you don't want to analyze the Excel file upfront to see if there is going to be some kind of an error in this process, so you prevent it, okay? No, you want to say, okay, I run this process file thingy that is, for me, it's a black box. I don't know what it really does or how it does it, okay? I hope that I know what it should do, okay, to calculate something from the Excel file, but I don't really care how it's done. Okay, I just know that if I give it a file name that doesn't exist, it will raise an exception, or if the data is somehow incorrect, then it might raise a 0 division error. Okay, so now I'm here and I need to deal with it. So I set here, okay, if it's a file not found error, I handle it. Now I can deal with it in different ways. One of them is saying except here, another except. And here I say 0 division error, okay? So, and here I can copy paste again what I put here. And say, I can't divide by 0. Okay, let's see. Now it works fine, okay? So, the user of that library, okay? Someone wrote that library, I don't know, that's the other student, okay? Who didn't attend this course, okay? That person, so they didn't handle the data correctly, okay? But we still need to use their library, and we can't change it, okay? Because they don't let us, because we don't, whatever. So what can we do? Well, we do this, we catch, that's the real word, we catch the exceptions. And the way we do it is that what I did is actually let's say the easy way, okay? I saw that there is an exception, which is called file not found. So I added to this code how to deal with a file not found error, this error message, and then go to the next file. 0 division error, can't divide by 0. Okay, print this out and go to the next file. I don't actually explicitly say go to the next file. It's just because it's in a loop, and it will go to the next file. But maybe you decide that if there is a 0 division error, then you don't want to keep the processing at all. Okay, so the other person, right, the person who wrote the mylib, doesn't know what to do in case of an error. That's why actually, that's part of the reason probably that person didn't handle these errors. That's why instead of writing this error handling, that person just wrote this analysis code, because they didn't know what to do. really, what should they do if there is a zero there in this division? Okay, they don't know. There shouldn't be the zero. So somehow something has to be done. And it might be you who know what to do. And what to do is, well, maybe, oh, just ignore it and go to the next one. It's a fine decision, but you have to make it. Or you can say, no, if there is, let's say, a divide, then break out from this whole loop and stop doing everything. So now if I run this, it won't handle the 3, okay, the case of the 3, because it says, okay, in this case, just stop running. Okay, so this allows me, or you in this case, to decide what to do in different types of errors. And we got to almost 9 o'clock, almost what, 10 o'clock. Okay. So I'm going to have a 10 minutes break now, and then we'll continue with this because there are a few more things about exception handling that I have to say. Any questions before we go on the break? Okay, so let's have a 10 minutes break.